Okay, guys, this lesson is on Unit 1, Day 5, Centers of Triangles. Okay, so with this lesson, we're going to talk about the different types of centers that triangles will have based off of based off of properties, and then we'll solve some problems. So starting with perpendicular bisectors, okay? So we have perpendicular bisectors, and the perpendicular bisectors here are XP, PZ, and PY. But they're also going to be using these dotted lines to help us solve problems later. So I want you to pay attention to those. What we also realize about this triangle with perpendicular bisectors is that it has division of the sides that are also congruent to each other. So BX is congruent to XA, BY is congruent to YC, AZ is congruent to ZC. Okay, so these pieces are congruent. Okay, so with that, we know that each perpendicular bisector extends to each side of the triangle. The point of concurrency is the point of intersection of perpendicular bisectors equidistant from the vertex, and it is called the circumcenter. Okay, circumcenter. So the circumcenter, with the circumcenter, we know that AP is congruent to BP, which is also congruent to CP. And then we have our angle bisectors. With our angle bisectors, we know that they're equidistant from each side again. So there's an equidistance from each side to the angle bisector, and that the point of concurrency of the three angles, which is this going to be this point here. Remember, the point of concurrency is the point where the three pieces meet. Okay, so the point of intersection of the three angles will be this dot here, is going to be called the incenter. Okay, and with that we have XP is congruent to YP, which is equal to ZP. Okay, we have all those parts. All right, pause it if you need to, copy that down. All right, medians. What we know about the medians is that they divide into two segments, okay? The median divides into two segments. The point of intersection of the three medians is this point here, right there at point P, and that is called the centroid. Okay, the centroid. So when you're solving for the centroid, what we know is that our line, so let's look at line AP. This is AP. That line AP equals 2/3 of the whole line, and the whole line will be line AY. Okay, so we know that AP is equal to 2/3 of AY. And then same thing with BP. That is equal to 2/3 of BZ. And CP will be equal to 2/3 of CX. And again, as a refresher, we're talking about the lines. So if I say AP, again, AP is this line right here. So this line AP will be 2/3 of the blue line right here, which is PY. Okay, 2/3 of that line. Alrighty. Then we have altitudes. The altitudes are like the height of a triangle. The altitude is the intersection of three of the altitudes is called the orthocenter. Okay, orthocenter. So the orthocenter is the point of concurrency of the intersection of the three altitudes. So this point right here at P would be called the orthocenter. Okay? Now, let's look at some problems in solving for centers. But before we do that, let's talk about this. So we have colorful, pretty bird. That's the same thing as the centroid and the perpendicular bisectors. And this is just words to help you remember the each center, okay? So you got colorful pretty bird, and when you think about that, you think of circumcenter, perpendicular bisectors, okay? Just the initials. Colorful pretty bird, circumcenter, perpendicular bisectors. Then we have crazy monkey, the C and the M, centroid medians. Crazy monkey, centroid medians. And then you have orange apple, orthocenter altitudes, orthocenter altitudes. And I am beautiful, in center angle bisectors. I am beautiful, in center angle bisectors. So this is just a fun way for you to remember each thing. All right, solving some of the problems. It says in the diagram, the perpendicular bisectors shown with the dashed segments of the triangle ABC meet at point G, the circumcenter, and are shown dashed. Find the indicated measure. Okay, we want to find the measure. So we want to find AG. Okay, so this line right here is AG. We want to find AG, which is that line right there. If we're looking at this complete triangle, we see that AG and CG are the same line. So if CG is 25, then AG should also be equal to 25. Okay? So then we want to find BD. BD is this line here. Remember when we were talking about the piece of the few pieces of the triangle before, we know that they have congruent sides when the segments are going to be congruent. So if the segments are congruent, we know that if AD is 20, then BD is also going to be 20. Okay? So I'm going to let you find CF and AB, okay, and CE, and then you should be able to find AC. So by using that little bit of information from these two pieces, you should be able to do the rest of those, okay? The next part, in the diagram, the perpendicular bisectors shown of triangle MEP meet at point O, the circumcenter, okay, the circumcenter. Find the indicated measure. So we want to find MO, okay? We want to find MO. So MO is this piece here. We want to find MO. So we can find MO because we know that when it comes to the perpendicular bisectors, each piece is congruent, okay? With that, each piece is congruent. So because each piece is going to be congruent, we know that this piece here is 26.8. And this piece here is also congruent to that. So if this is 26.8, then MO is also going to be 26.8. Okay? Then, so right here, this is, that is P. That is point P. Down here, we want to find MN. Okay? We're going to try to find MN. So, in order for us to find MN, which is going to be this whole piece here, okay, this whole piece here, we know that MQ is 20. So, because we know that MQ is 20, this piece and this piece are congruent. So, because these two pieces are congruent, if this is 20, then this piece should be 20. So, my whole thing is going to equal 40. Okay, so you're going to find those, the rest of those, and let's talk about the measure of angle MQN. Okay, let's talk about the measure of angle MQN. Now, the measure of angle MQN, let's highlight that angle. MQO, I keep saying MQN, MQO. Okay, let's look at MQO. My angle is not straight, but you're going to get the point. MQO. So if we're looking at MQO, that angle identifies as what type of angle to you? MQO, this angle here. Now we're talking about perpendicular bisectors. So because we're talking about perpendicular bisectors, one thing we know about perpendicular bisectors is that if it's perpendicular, that perpendicular bisectors create 90-degree angles. So if this is a straight line and it is a perpendicular bisector here, then this is going to be a right angle. So because that's a right angle, then the measure of angle MQO is 90 degrees. Okay? Lastly, we want to find OP. It says OP, which is this line down here, is equal to 2x. Okay? And we want to find x. We know that OP and ON are equal. So 2x is going to be equal to 26.8. Because again, as I stated before, that those two pieces are going to be congruent. Okay? So if OP is 2x and 26.8 is ON, then 2x equals 26.8. So what we need to do to solve for that is that we're going to divide by 2 on both sides, and then x equals 13.4. Okay. All right. Point T is the end center of triangle PQR. Okay, PQR. And question 25 says if point T is the end center, then point T is the point of concurrency of the, and we got to think. Remember, I gave you those words. I am beautiful. A and B. A and B stand for angle bisectors. So the point of concurrency is angle bisectors. So we have our point of concurrency here. And then 26, for question 26, it says ST equals. We got to figure out what ST equals. We know that WT is 15. So if WT is 15 and TU is also congruent and ST is also congruent because they're all perpendicular bisectors, then if WT is 15, then ST should also be 15. Okay? And then for 27, it says if TU equals 2x minus 1, we want to find x. So it's telling us that TU is equal to 2x minus 1. And we want to find x. Now, again, we just said that this right here was equal to 15. So that means this right here is also going to be equal to 15. But if it's telling you that it's 2x minus 1, then we know that 2x minus 1 equals 15. So we just solve it now. We solve it for x. So we're going to add 1 to both sides. And 2x equals 16. Divide by 2. X equals 8. And we found 8. I'm sorry, x. Okay? All right. Centroid is the next piece. So centroid. Point G is the centroid of triangle ABC. AD equals 8. Okay? So it's telling us some pieces. So the first thing you do when you're given this type of information in a problem, underline what is important. Okay? Underline what is important. It told us that AD is equal to 8. AG right here is equal to 10. BE, so this right here is BE. We know that's equal to 10, so we're going to label that 10. AC, which is this whole line here, is going to be equal to 16. And CD equals 18. So that whole line for CD equals 18. Okay? That whole line equals 18. Okay? We're going to put 18 right there on top of it. All right. So now the question says the point G is the centroid. Point T is the point of concurrency. Okay, if point T is the point of concurrency of the what? Of the what? So we had I am beautiful, crazy what? Right, crazy monkey. So if you're a crazy monkey and you had a centroid, then centroid is the CM stands for crazy monkey. So the centroid, the M word stands for medians. Okay, you have your medians. Okay, all right. So centroid, medians, crazy monkey, centroid, medians. All right. So we want to find DB. So we can find DB because we know that AD is equal to 8. So again, this is congruent to that. So DB is also going to equal 8. All right. And then we want to find EA. Okay, EA. So we want to find EA. EA is going to be this long line all the way down here. Okay. All we know about this is that AG is equal to 10, but we got to find EG in order to find the whole thing. So because GA is 10, we can find EG. Now, in the formulas that I gave you, I told you that the whole line, the long side is 2/3 and the short side is 1/3. Okay, you got to remember that because the whole piece is going to be a whole. So this is 2/3 and then this side is 1/3. Okay, so what I think about when I do this is I be like, okay, if a whole line is going to be 3 parts. Okay, if a whole line is 3 parts, okay, and this is 1 part and this is 2 parts, I already know what my 2 parts is. So I'm going to take that 10 and divide it by 2 because I got to find the 2 parts of that 10. So 10 divided by 2 is equal to 5. So that way I know now that that 1 part that is left is also equal to 5. So my whole line is 10 plus 5, which gives me 15. Okay, so I want you to use what I just did, and I want you to find CG. Okay, well, I'll help you find CG because this one's a little different. Okay, so let's do the same thing, and let's find CG. Okay, so when we find CG, we know that the whole thing was 18. Okay, I'm sorry, CD. So the whole thing was 18. Again, so CD equals 18. But again, the line together is 3 separate parts. Well, it's 2 lines, but we know it's divided into 3 parts. So my longest side, which is CG, is 2/3. And my short side, GD, is 1/3. So I'm going to take 18 and I'm going to divide it by 3. So I can get 3 equal parts. Okay? So 18 divided by 3 equals 6. So now it's asking us to find CG. Okay? So if I'm finding CG, I know CG is 2 parts. So 6 times 2 is going to give me 12. So CG is equal to 12. All right. So now BA, I know you can find that on your own. So I'm going to let you find that one. All right. So now the next couple of questions, you're going to do this on your own, thinking about all the stuff I gave you, information I gave you, and write down the names of the points of concurrency, and then fill in the blank statements here. Let's do that together. The incenter of a triangle, okay, the incenter of a triangle is equidistant from the blank of the triangle. It's always going to be equidistant from the sides. Okay, the incenter of a triangle is equidistant from the sides of the triangle. Okay, the circumcenter of a triangle is equidistant from the angles. Okay, the circumcenter is equidistant from the angles of the triangle. Okay. And then the centroid is blank the distance from each vertex to the point of the opposite side. The centroid is 2/3 of the distance from each vertex to the midpoint of the opposite side. Okay, so fill in what each piece of the which each center of here is going to be, and then that's the end of our notes. Okay, all right, guys.